There are different ways to see and measure the performance of an application. Generally, the developers see and measure it in terms of speed, and they measure things like transactions per second or GBs of data processed. But if you are an architect, you may measure performance in broader metrics. You will be more concerned about resource utilization or performance of connections between services. Similarly, if you are from the business side, then you will measure the application performance in terms of the amount of resource invested, the amount of money invested. So resource allocation would be your criteria, and so on and so forth. But somewhere all these metrics are important and they have their own place. So, in simple words, we can say that optimizing the performance of an application is about improving its speed, efficiency, and resource utilization. The first step to improve the performance of your Java application is about finding the right set of tools. That means knowing not just how the Java language works, but also how the JVM libraries, memory, the compiler, the garbage collectors, and the hardware your apps run on are interacting. There are several tools and techniques available for optimizing and improving the performance of Java programs. For example, profiling tools can be used to identify the most time consuming parts of the program, while memory analysis tool can help to identify and eliminate the memory leaks. And additionally, using caching techniques and optimizing database queries can also improve the performance of the overall Java program. It is important here to mention that most of the time, the execution pace of Java code depends on the underlying JVM. An old piece of Java code may well execute faster on a more recent JVM, even without recompiling the Java source code. So, as a process, optimization is about identifying and eliminating the bottlenecks in the code that slow its pace or consume too much memory and resources. This may involve using algorithms that are better suited to the problem being solved, reducing the number of operations performed, or improving the data structures used by the program. And performance can be defined as the actual speed and efficiency of the program in practice. Now, let's talk about some basic performance metrics. In the basic set of performance metrics, we have throughput, latency, capacity, utilization, efficiency, scalability, and degradation. It is important to note that for most performance projects, not every metric will be optimized simultaneously. Generally, we see the case of only a few metrics being improved in a single performance iteration. And sometimes, optimizing one metric comes at the cost of another metric or group of metrics. So let's discuss them one by one. The first is throughput. It's a measure of the amount of work that a system can perform within a given period of time. This is usually expressed as number of units of work in some time period. For example, we might be interested to know in how many transactions per second a system can execute. Like in the context of a web server, throughput can be measured in terms of number of requests that the server can handle per second. In case of a database system, throughput might be measured in terms of the number of queries that can be processed per second. Throughput is influenced by a variety of factors, including the speed of the system CPU, the amount of available memory, the efficiency of the system's IO operations, and the efficiency of the system's software. So, measuring and optimizing throughput is an important consideration in the design and development of high performance systems. It can help to ensure that the system can handle the expected workload and that user receive the best possible experience. Next, we have the latency. It is the time taken to process a single transaction. In other words, it is the time delay between a user initiating an action and the system or application responding to that action. It is normally quoted as an end to end time. To minimize latency, system and applications may employ techniques such as caching, load balancing, and optimized network protocols. In addition, measuring and monitoring latency can help identify bottlenecks and performance issues that may need to be addressed. Next, we have the capacity. Capacity is the amount of work in parallelism a system can process. That is the number of units of work that are running simultaneously. So, how much you can possess in parallel at a time, that is your capacity. It is generally related to the throughput, which is the speed of the system. The more concurrent your system is, the more its throughput and latency will be affected. That is why it is often referred as processing available at a given value of latency or throughput. Next, we have utilization. One of the most common performance analysis tasks is to achieve efficient use of a system's resources. It's about how efficiently you are able to utilize your system's resources. And depending on the workload, there can be huge difference between the utilization levels of different resources. Next is efficiency, which is the ability of a system, process, or algorithm to perform a task or function using the minimum amount of resources possible. In other words, it's a measure of how well a system or process can accomplish a given goal while using the least amount of time, energy, or other resources. Dividing the throughput of a system by the utilized resources gives a measure of the overall efficiency of the system. And this makes sense as well, as requiring more resources to produce the same throughput is one useful definition of being less efficient. Another important metric is scalability. Scalability is the ability of a system or application to handle an increasing amount of work or traffic without compromising its performance or stability. In other words, it is the ability to scale up or down in response to changes in demand while maintaining the high levels of reliability, availability, and performance. The throughput or capacity of a system depends upon the resources available for processing. The change in throughput as resources are added is one measure of the scalability of a system or application. So, scalability can be achieved by a variety of techniques, including horizontal scaling, that is, adding more computing resources like server or virtual machine to handle the increased demand, vertical scaling, adding more resources like CPU, memory, or storage capacity to a single server or virtual machine. Load balancing, distribution of incoming traffic across multiple servers to avoid overloading any one server. Then sometimes we use the caching, which is storing frequently accessed data in memory to reduce the number of requests that must be processed by the server. And we also sometimes apply the asynchronous processing, which is offloading time consuming task to a separate thread or process to free up the resources for the other request. But at the same time, it is important to note that systems scalability is depend upon a number of factors, and it is not normally a simple constant factor. And the last metric in the set is degradation. Degradation refers to a decline in the performance or functionality of a system or application over time. When a system or application experiences degradation, it may become slower, less reliable, or less responsive, which can negatively impact user experience and business outcomes. If we increase the load on a system, either by increasing the number of requests or by increasing the speed requests arrive at, then we may see a change in the observed latency or throughput. It is important to note that this change is dependent on utilization. If the system or resources are fully utilized, then we would expect to see the throughput stop increasing or latency increase. So it is these changes that we usually call the degradation of the system under additional load. So these are some of the basic performance metrics related to Java program. Although these metrics are universal, they can be applied to any sort of program. In a nutshell, we can say that optimizing the performance of Java is basically a process of improving the speed, efficiency, and resource utilization of Java programs. The more you will understand the internals of your system, the better you will be able to optimize it. That's why these days we hear the idea of mechanical sympathy. So, having some mechanical sympathy with the system that you use and work on is crucial.